Hi guys, welcome to Codewell and welcome to the day 2 of the algorithm series, that is 14 days to crack the algorithm. So without wasting much time, let's start today's question. So let's go with the first question, that is squares of the sorted array. Cool. So let's see the question first. So what they're asking, they have given an array num sorted in non-decreasing order, and we have to return the squares of each number in a non-decreasing order. Cool. So this is the array, so there can be a negative values also, we have to keep that in mind. So it says -4 -1 0 3. So what will be the sorted order? That is 0 1 2 3. Like when we square a number, it will be in this form, right? We have to sort it. So, how can we do this? So, we have to do it using a two-pointer approach, right? So, one thing can you observe? What? What is it? Let us take any number. If it is even the, let's take if there is a negative number, -3, -2, -1, 0, 1, 2. If this is total number, you can see that if we take the absolute, if we are taking the absolute of the number, if what is absolute of 3 -3, it is 3, right? So if you take the absolute of all the number, we can see that it's like in this decreasing order, right? It's like this, it's like a steep, like, right, increasing to decreasing, increasing to decreasing. If you take the absolute value, right? If it is starting from 0 1 2 3, that time also it's sort of a steep, right? Right. So what can we do is, we can take a two pointer that, let's set, if we know that in two pointer there is two pointer, that is left and right pointer. We'll set the right pointer to the last index and left pointer to the first index. What we do is, we put a condition where that till this will reach here, and what we'll do is, we'll check first if the absolute of this, absolute of left, is greater than absolute of right. If that is the case, we include the number and make it a square. We are not checking it side by side, we are checking it, uh, we are checking the left number and the right number, if this is greater than this, because we know that at the extreme position only we get the um, larger number, as we have seen, that is there's a steep, so we can see that at the edges only we have the greater number, right? So we can, what do we do is, what will be our approach is, we we take the absolute of this number and we check which is greater. For example, let's dry run this. -3, if we take the absolute, it is 3. So 3 is greater than 2. Yes, it is. So what we do is, we take a vector and push the square of this number inside it. So it will be 9, right? And once this is inserted, we increase the pointer, that is L plus plus. Now L will be pointing here. Now again we check if this is greater than or equal to, this will be the greater than or equal to. So if L is greater than or equal to 2, yes it is, absolute of 2 is equal to the absolute of 2. So what we do is, we push this again, we get 4. Again we increase the pointer. Now this condition fails, the absolute of left is greater than equal to absolute of right. So what do we keep in the else condition is, or else push the left index, we square it and push it, so we get 4. And now decrease the pointer of r will be pointing here. And finally, after this all this calculation, we get 1 1 0, right? But what is the main deal now? They have said we have to we have to sort it in non-decreasing order, right? But we have it in the decreasing order. but we wanted non-decreasing order, so we just reverse this, right? That's it. Then we get our um, answer. So let's code it real quick. So yeah, we this is the code. So in this, as we discussed, we took the L and the R. We take vector. We check if the right is always greater, and we check the absolute of L is always greater than absolute of R. We can do less than or equal to also. It's fine, or else even this works. And after doing this, at the end we reverse it and return the answer. So let's uh, submit this. Okay, sorry. Now let's do it. It's okay. Let's submit. Yes. So now let's go to the second question. The what is the second question? So they're asking, they are given an array. We have to rotate the array to a right by k steps, where k is non-negative. So if this is an array, if they're saying we have to shift k steps, that is 3 steps. That is, we have to from the right. That is, we point. I mean, we take this 7 and insert at the first. That is 1 step, 2 step, and 3 step. So it will be 5, 6, 7. Right? You can see the dry run over here. First 7 will go, then 6, then 5. So we have to return this. When goes with the same with the k equal to 2, that is 99, and 3 will move forward. Right? How can we do this? Let's discuss. Can you observe one thing? What? Let me just discuss. Basically, it's a medium level question, but you can do this in an easy way. That is, let's take an example. We have 1, 2, 3, 4, right? So they are saying you have to move k equal to the k value is 2, right? So we have to, so our output should be like 3, 4, 1, 2, right? This should be our answer. So what is the easy way is just what how we can solve this in an easy way is just what we do is we just reverse everything once. So what will be the reverse value? It will be 4, 3, 2, 1, right? So we know that this has to be reversed, right? This has to be reversed. The k2 value should be reversed, right? And this should be reversed. Can you see the can you see the can you make out the difference right now? Yeah, just we have to reverse this, and we have to reverse this. So again we have to reverse this first and this first, and we'll get the answer. That's it. We have to use 3 reverse functions that to get this function. That's it. That's the easiest solution. So let's code that too. So So this will be the solution. So why we are taking k equal to k mod n? Because sometimes if it is out of bound, that time it might be a problem. So we are taking this. And as we said, first reversing everything, then we are writing the first k elements, then after k elements. Let's run this. Yes, working. I hope even you are doing simultaneously. Please do it simultaneously, or else you'll never learn. And yeah, stay tuned. Let's meet tomorrow with the day 3. And keep coding, be safe, and yeah.